afternoon, I'm Martí Esteso, and in this video we are going to see how to solve this equation. Well, first of all, we need to do the minimum common multiple to be able to have the same denominator in all of the parts of the equation. As we can see here, we are doing x minus 2 and square x minus 4x plus 4. To factorize the second term and make it possible, we need to apply Ruffini's method. As we can see here, we have found our two solutions. The first one, as the main number is 2, is x minus 2, and the second one is also x minus 2. So we can say that the factorization of the second term equals x minus 2 squared. So we will have it very easy, as the first term is also x minus 2. The next step is to add it all to the denominator of the equation, and then to do the required operations to be equal. When we finish this step and we have the same number in all of the denominators, we are able to remove them and only take the above part. Then we solve the operations and we summarize the equation, putting together all of the equal terms. We can see that the final term equals a second-grade equation. We solve it and we take our final results. Hello, I'm Martí Esteso, and now I am going to operate and to make the solution of the second equation. The first step is to solve the operations that we can. So we multiply both square roots to summarize the equation. To be able to take out the square root, we pass the x to the other side. When we have it there, we elevate to square both sides of the equation, and after doing this, we erase the square root. The next step is to operate and put together the similar numbers, and we observe that it is again a second-grade equation. But before arriving to this part, we have to stop in the square operation of 2 plus x. Here we have to use the methods of notable products. The next step, as I said before, is to group the similar numbers. Then we start solving the second-grade equation with the formula we have in the screen. But very soon we face with a problem. When we start operating, we bump with an error. The interior number of the square root is negative, so the expression is not defined by the group of real numbers. Hello, I am Martí Esteso, and now I'm going to solve the third problem, the extra one. In this case, it's all of the time the same step. We need to elevate to square both members of the equation to be able to eliminate one by one all of the square roots. Then, to add the single number to the other side, repeating this all of the time, we will solve the equation. It can be a bit annoying, and it is easy to make a mistake with some of the terms, but it is all practice.